So a few months ago, I talked about, maybe 3 months ago, the initial support to have loadable native code. So by native code, I mean code not Python anymore, but you write in C or maybe Fortran, and you compile it to machine code, and then to be able to import that code as like a normal Python module. So your Python code doesn't know the difference between importing something that's Python or importing something that's C or Fortran perhaps. So it's all just transparent to what the Python code is doing. So I showed you some demonstration then, and so this is sort of part 2 of that, where it's a lot more user-friendly basically. So you can very easily write some code in C and then plug it into your Python code. And this was work done with Matt and for Matt's talk at PyCon, and then, well, you know, all so that everyone can benefit from it. So there's a whole, this is going to go up as a pull request soon, and then as part of the repository, so it's not publicly available just yet. It probably will be tomorrow, but there's a bunch of tools that I wrote, mainly is this ELF to MPY, which converts the ELF file to an MPY file. It's just got a bunch of boring things in it, but the point is it helps you to make something very easily. So in this example directory, I've got a make file, which is quite simple. It just has a few lines just to define your source code. Maybe if I edit it better. You define the name of your module that you want to make, so example 0 here, and the architecture you want to compile for. So I'll start by compiling it for 64-bit Intel, and then you just include this sort of this boilerplate stuff, and it lets you do it. So let's have a look at example 0.c. So here we're writing in C, but we're trying to write something that can be plugged into Python. So at the bottom here I have the initialization function. So when you import your module, this is the thing that will run. And it's got some little macros here that you just put there, and they'll do some magic stuff behind the scenes. But the things you want to do are the thing in the middle. And here we're basically making a function out of foo, which is up here. It's a C function, and we're storing it to the global called foo. So we're making a function called foo. And in foo, we have this initialization, and we can do it if we like in C, and we can return something. So let's make it return something a bit more interesting than none. So make a number as, say, the number of arguments times, say, 2. So nargs will be the number of arguments you've supplied to this function. So this is all we have to do to make a simple one-line function there in C. And if I make that by typing make, so it does a bit of stuff here. It's got some cryptic things that are printed out just to explain sort of what's going on. But in the end, it's made a MPY file here, ex0mpy, which is your C code packaged into a module that you can import. And you can see its size, 235 bytes. And we can have a look inside it. It's just it's the machine code that does what you've coded in C there, plus a little wrapper here. It's called foo. You can see that down here. So if we run MicroPython and we import that x0 and tab complete, you can see it's got this foo thing, which is a function. And if we call it with no arguments, it should return 0. If we call it with 3 arguments, it should return 6. So that's our function we've written in C. And so let's write, say, another function. Let's write a function called bar, say, and it can call some factorial, say. So this works. What do we do? Turn 1, turn x times factorial. 1. And instead of calling it bar, let's call it factorial. I can't do that.
return. So we need to pass it an argument. So MP object. Okay, I need some int here. Get int will do. Just needed to know what was actually working. Args naught. So the first argument we'll take the factorial of. Okay, and then we need to also store that into our table here. We can, yeah, okay. So I've just written a simple factorial function there, and let's see if it works. No, because this was supposed to be helper. Okay, and then let's see how big it is. 353 bytes, it's not too big still. So that's the code now. And if we go MicroPython, import example 0 dot factorial, let's do factorial of 4 because we know what that should be. 4 times 3 is 12 times 2 is 24. Okay, that's right. So 4 times 5, 120. And if we go too high, yeah, it's going to wrap around because it's only using small integers. It's not using big numbers. So, and obviously it's going to be faster than the Python version. So eventually it'll wrap around 19. Yeah, so it's going smaller now. So that's good. But let's to show you that how to. So this is running on my computer. I can make it run on a Pi board by changing the architecture. Rebuild. So the same code there is now quite a bit smaller file because ARM is a more condensed instruction set. So this is the code for a board, STM board. So let's copy that onto our Pi board. Copy excellent. Okay, and have a look. Okay, so import. So now I'm running. Sorry, on this Pi board here, the same code. Import example 0 dot foo with say a few arguments. We can't double my arguments. And factorial of let's do factorial 10 or 5. That's correct. So that same C code runs on yeah, on the Pi board or on the computer PC very easily. So you can very easily just write some C code here. You don't have access to every single thing you'd like. You can't really do printf. You can do lots of other things though. So in Matt's talk, he gave the example of generating a QR code. So I have, again, the makefile here. It's just very simple. My module is called QR, and I'm building it for an Intel machine and QR.c. Okay, so at the bottom I have this initialization, which makes the function called convert, which is the QR thingy, and some constants low, medium, high, or quartile and high, which is how much error correction I think to do. And then there's one function called convert, which is on this page. It just unpacks the arguments, calls the function to do the QR code generation, and then produces a tuple of tuples as a result at the end here. So this is all written in C, but the main thing is that I'm including the actual QR code gen implementation, which is just something that Matt downloaded off the internet and gave to me. I didn't touch this at all, so this is literally just as is code. It's like you can see it's 1,000 lines of C code with lots of stuff happening, and we're going to compile this into a module to import directly. By just doing make. Okay, I did it before. We'll do make B. So here, so it's got a lot more information to bring out because these are all the symbols that it's using in there. And we can see that the resulting MPY file is about 8 kilobytes, and that will run on my laptop here. Oh, so it's QR now, and QR convert test. So this will create a QR code with the text test in it, and I'll just try and print it out in a more. Okay, so you can maybe see that's a QR code. Like it's got boxes here and boxes there. I try and render it a bit better, but you can see that it's actually works.
It's magic eye.
And then again, I can just quickly to prove the point that you can run this. So built for ARM, it's about 6 kilobytes. So copy that across to the PyBoard, and then this would be run it, import QR. So now I'm on the PyBoard here. So QR.convert, test again, and yeah, so that's the same QR code just generated on the microcontroller with that same C code. So it's very easy to just take any C code you like, well, almost any C code, and make a module out of it that you can just plug into your Python. And I didn't have to compile any firmware or download any firmware or anything.
That's really good.
So yeah, that's the end. But this will be publicly available very soon, very soon.
Wrapper code? Just in here as wrapper.
Sorry,
The wrapper code?
X0.C.
Yeah. Just because, like, so before I referred to a couple of tools to do the C stubbing of the boilerplate. So what these tools do is help you generate those MP globals, MPQ strings at the bottom there, just by specifying what functions you want to wrap up and what you want to provide to MicroPython. So perhaps now you can sort of see why those tools got a lot of interest there after we talked about this stuff. And now we can add init and entry and
Yeah, there's a few things to modify to make it work with this, but it's otherwise should be similar. I tried to make it as simple as possible.
Yeah. Cool. That's really
Okay.
Thank you.
Thanks, Dan. That's